Everyone has creative ideas, but bringing to life ideas involving software and electronics can still be quite a challenge. Today, we're changing that. We're building a platform that enables anyone to create with software and electronics as easily as drawing a flowchart. We call it Qubit. My name is Tim. I'm a co-founder of QFusion Labs and the lead programmer on Qubit. Usually, creating an electronic project means writing code and soldering. There's a steep learning curve just to set up an LCD screen. With Qubit, anyone can do it. Instead of writing code, you can express your logic visually. Instead of soldering, just plug in a single connector and the wiring is done. All you need is the Qubit controller, plug-and-play Qubit smartwares, and our drag-and-drop app, Qubit Workshop. Everything starts with an idea. We built Qubit from scratch, designing every software and electronic component to work seamlessly together. When you connect something to the controller, it's instantly recognized and ready to use in the workshop. If you can make a flowchart, you can make a program in Workshop. Just drag and drop to control any smartware. Hit launch to send your program wirelessly to the controller and watch your vision come to life.
My name is Jason Gao, and I'm a co-founder of QFusion Labs. Before Qubit, I was an electrical engineer. In second grade, my dad had taught me basic electronics and programming, and it opened up a world of new things I could create, and I've always wanted to share that experience with everyone.
I'm Marvin, and I'm also co-founder of QFusion Labs. Growing up, my brother Jason was always more into hardware, and I was always more into software. We said, let's create something that would make life easier for the both of us. We wanted to make it simple to create new projects, allowing us to focus more on the ideas instead of having to solve hardware or software problems.
One fun project we did, we called the Secret Bookshelf Trigger. It's like something out of Indiana Jones. There's a qubit inside that book that sends a signal wirelessly to another qubit inside a wooden chest that opens up on its own and illuminates the LED.
My name is Kasia Obietkova and I'm an interaction designer. I use Qubit to work on my interactive art projects, particularly programming light and motion. It was incredibly easy to use. I didn't need to go into any of the technical details and could really focus on the design.
Qubit is easy to learn, but it's also a powerful platform that will grow with you. For more experienced makers, we provide a library that allows you to control hardware directly. You can create custom blocks and even create your own smartware. Imagine if you could automate your home, add movement to your art project, or create a one-of-a-kind toy for your kids. What will you build with Qubit?
Hi, I'm Bruno Sinopoli, and I'm part of the UDO team. Today, more and more projects on physical computing require assembling Arduino microcontroller, single-board computer, motion sensors, and wireless connection such as Wi-Fi or Bluetooth. Now, you can have all of this with UDO Neo, single board of the size of a credit card. UDO Neo allows you to build tons of creative projects for the Internet of Things, such as smart homes, drones, education tools, funny robots, apps for cars and bikes, social lights, interactive audio players, ambient sensors, and you can even power it up with a normal battery pack.
Hi guys! Back in 2013, we have launched UDO on Kickstarter, an open hardware single-board computer that combines the simplicity of Arduino and the power of Android and Linux. In 2 years, dozens of projects powered by UDO have been created by a vibrant community of makers, designers and developers. UDO Neo pushes further the flexibility of UDO. The Arduino-compatible microcontroller and Android Linux computer are now embedded on the same chip. The board is very small and flexible. It embeds Wi-Fi, Bluetooth, and 9-axis motion sensors. UDO Neo is compatible with Arduino Uno pinout. Neo also embeds all the common I/O of a personal computer. Let's discover how simple it is to develop amazing projects with UDO Neo.
There are many ways to use UDO Neo. You can use it as a normal Arduino board. Just plug it into your computer and program it using the official Arduino IDE. But UDO Neo gives you even more flexibility. In fact, you can use it as an Android Linux computer and program in any language you want. Thanks to this flexibility, UDO Neo allows you to realize any project you can imagine.
Neo is ideal as an educational tool. You can use it for introducing physical computing to humanities students, or the design of real-world computing system to computer science students, or even for exploring the potentialities of cyber-physical system in computer architecture classroom.
UDO Neo is the perfect board to make drones. It has motion sensor to stabilize movement in the air and kill vibration. With Bluetooth 4.0 module, you can control the drone with smartphone and tablet.
UDO Neo is the perfect solution for my smart home. It senses my presence using Bluetooth Low Energy and detects my movements using motion sensors. With R4 microcontroller, I can interact with physical world managing lights and home appliances. Using the Wi-Fi, I can connect to the internet and control my home when I'm away.
This is CHIP, the world's first $9 computer.
Connect over composite, VGA, or HDMI.
CHIP does computer things. Save your documents to CHIP's onboard storage. Surf the web over Wi-Fi. Play games with a Bluetooth controller. But wait, there's more.
This is Pocket Chip. It makes CHIP portable. Take CHIP, put it into Pocket Chip, and you can use CHIP anywhere.
You might have noticed, CHIP looks a little different than every other computer.
Because we built CHIP to fit into your projects.
And we're so excited to see what you can do with a $9 computer.
Blink Blink is a series of creative circuit kits and an online platform that engages girls with technology and engineering through arts, crafts, and fashion projects.
Jocelyn and I really wanted to co-design the kits with girls, so we started hosting workshops where we'd bring one or two materials and we'd ask the girls to build projects and just see if they liked the material, ask them what kind of materials they wanted. And we also tried to design Blink Blink aesthetically with them.